So to go back to the main point, probability, it's just counting people from a population. Now we understand a bit better what a population is. We understand a bit better why we care about population, what samples are, kind of where we're going to go in the future. Let's get back now to probability. So the definition of probability is quite simple. Relative to a population, it's just the proportion of the population in which some kind of thing happens. So in this little example, we've got two kinds of people, pink people and black people. You can imagine that the color represents some kind of event of interest, maybe people with a particular disease. So if we ask about what's the probability of having that disease or what's the probability of somebody being pink, it's just the number of people who are pink divided by the total number of people in that population. So the black outline just represents any person of any color in this kind of schematic. It's just a proportion. It's just a fraction. That is it. Of course, we don't usually know what these things are because we don't have the whole population. We don't know what this numerator is. We don't know what the denominator is. But again, for the purposes of understanding these concepts for the next few weeks, we're going to suspend our disbelief and kind of imagine, if you did know, how would you manipulate these things and kind of come to understand what's going on here. So probabilities are abstract ideas. Typically, we're using them to reason with. We're guessing about them. We are almost never measuring these proportions directly. Okay. Okay, so in this example, we've got 16 people in our little comic population, and 6 of them are pink. So the probability of being pink is very simply 6 out of 16, which reduces to 3 out of 8. Okay, so here's something else. Maybe let's say we're measuring not only what color these people are, but whether or not they're wearing a hat. Okay. Again, this could represent another disease or whether or not they live in a particular place, whatever. So the probability of having a hat here, since there's 4 people with hats, is 4 out of 16, or 1 in 4. Okay, so now we have 2 kinds of things that are going on. We can also start to ask about probability of either of these being true. So what's the probability that somebody is wearing a hat or they are pink? Either of them counts. That we could just take the number of people who are pink or wearing a hat. So here it would be, just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 16 should be the answer. What I'm showing you here is that another way to count to 9 is to count first how many pink people there are, and then add the number of people who are wearing hats, and then subtract off however many people you double counted. Because if you add together, if you count first 1, 2, 3, 4, 5, 6, and then count 1, 2, 3, 4, I've counted this little guy here twice because they are wearing a hat and they are pink. So to get rid of it, this person, I need to uncount them because, and the number of people that I'll have double counted is exactly the number of people who are both wearing a hat and are pink. That should be pretty elementary and clear. So when you look at these kinds of counting, these formulas expressed in terms of counting, they're pretty obvious. For some reason, they tend to become much more mysterious when you talk about it in terms of probability, but it's literally the same thing because from here, all I've done to go from here to here is divide by the denominator everywhere. So everything divided by 16. Okay. So the point of starting out with this is to illustrate that when you're talking about probabilities, you can always just think about counting in a population and dividing by the total number of people in the population, and all of the kind of like rules and formulas and blah 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 that people talk about, it all reduces down to just counting, ways of counting, and what you need to uncount or double count or whatever. Okay, so throughout the course, we're going to have these red slides that pop up. Here, I want to ask you to, if you're watching at home, pause the video and read this to yourself and just think about it. It'll really help your understanding if you do that and you attempt these problems. Of course, I'm going to now explain them, but it really will help your understanding if you always stop it and don't just kind of think about it and be like, okay, I know how to do that, but like actually work it out and make sure that you're either totally getting stuck or you can get to the end before starting the video again. So go ahead and do that now. Okay, so what this is asking about is, let's say that I've defined my population as everyone in New Zealand, and I'm defining a couple of probabilities. One is the probability of being older than 65. The other is the probability of being diabetic. And then the last one is the probability of being older than 65 and also having diabetes at the same time. So you need both of those. And now I'm asking how many people are either over 65 or have diabetes. So this is totally equivalent to this because, let's say the pink thing is like having diabetes, the red hat is being over 65. This is all the people who are both diabetic and over 65. And what we're after is this quantity here, which is the number of people who are either 65 or older or have diabetes. So all we need to do is add these two numbers and subtract off this number. So that's 3 plus 2 minus 1 is 4 over 20, or 1/5. So that one is pretty straightforward. So what 1/5 is the probability, right? So if there are 5 million people total in New Zealand, and what was it? 1 out of 5 of them are meet this condition, then that is a total of 1 million. Okay, so let's run this code. What we're going to do now, I'm just going to show you how in R we can, typically in a real world setting, you don't have a population data set. You only measure stuff about your sample, right? But since we're learning and playing, why don't we just play God? Why don't we just pretend like we do have the whole population data set so we can understand these formulas a little bit better and play around. So you can go ahead and copy this code right now into R and run it. A bit bigger. Okay, so all I've done is I've copied that in there, and you should see a new data frame has been created, and it has 5 million observations of 4 variables. So I've imagined that I've done a giant census like survey for everyone in New Zealand. So for everyone in New Zealand, I have collected. We can actually, I think, open this up here. Yeah. So for everyone in New Zealand, I've collected. I've given them an ID number. I've recorded their age, and based on their age, whether or not they're considered to be a senior citizen, and I've recorded whether or not they have diabetes. Where did these data came from? I totally made it up. So if you can look at this code here, if it makes sense to you, great. If it doesn't matter. Just know that this is like fake data. And we'll talk about how to do this kind of thing so that you can play around with this kind of stuff yourself and make up your own fake populations. We'll talk about that a little bit later in the course. It's a super effective tool to understand statistics. We can, as we'll see in a second, what the kinds of stuff that we can do with that. So now that you have that, we can go here. And what this question is asking is just asking you to calculate a couple of proportions or probabilities from that population. So we want to know what the probability of being senior is, probability of being diabetic, and the logical or and conjunction of those two. So go ahead and try that out for yourself. This is also a good time to mention, I have here, some tips for you. And if you haven't yet used ChatGPT, it's a really good resource, especially for learning kind of introductory R and statistics stuff at like roughly an undergrad level. It's really good. Of course, it starts hallucinating more and falls apart when you get to more advanced topics. But like every other tool, you just have to know how to use it. So for really basic stuff like what we're doing right now, it'll just be able to tell you exactly what it is you need to be doing. As we go further on in the course, if you're using it, which I do recommend you use it to kind of help yourself understand what's going on. Some tips I have is like, okay, instead of giving it the whole problem, maybe say, give me an outline of kind of how to tackle this, and then do each thing in steps and figure out where you're getting stuck, and then work on that, because it can sometimes not have the greatest like end-to-end performance, but if you chunk problems up, it can break it down and do a bit better. Um, and just a quick tip about like coding in R, I recommend if you're asking it about like programming stuff, um, firstly ask it to use the tidyverse as much as possible. Because then everything will be very consistent and you don't have to learn. Like in R, there's like 3 or 4 ways to do most things, and they're all bad except for the tidyverse way. By bad, I mean like, it does the same thing, but it's not as readable, and it won't help you actually understand what's going on as much as I think the tidyverse way of doing it, which is it's very consistent, it's clear, and it's kind of to the point. So I kind of prefer that. There's I would also recommend like when ChatGPT, if you're using it to get code, always if there's anything that you don't understand, why it gave it to you like that, just ask, right? Say like, why did you use this function here, or what is this thing doing? What's this argument? Why did you have to say by equals this? Or is there a different way that you could do this that might make more sense to me? And then compare and contrast the result, or like what you could ask it to quiz you, right? You could say, if I do this kind of thing, what should happen, or give me some kind of quiz questions to help me understand this code that you do, where I have to write some code to like plug it in. So it can really be useful in those sorts of ways if you take the time. Don't just copy paste what ChatGPT gives you is kind of what I'm trying to say. So anyways, that's a long detour about ChatGPT, and of course you should use Google, other resources like that, in the same kind of didactic way, instead of just trying to get the answer and move on. Use it to help you understand. All right. Okay, so let's get back to this. We're just calculating some probabilities. As we know, probabilities, it's just counting how many times something happens and then dividing by the total number of people in the population. So all we need to do is count. That's it. How do we count? Let's start out with senior. You know what? Let me start a little script here. One place. So I have this data frame called population, and in tidyverse filter, we'll get rid of rows. So all I'm going to do is filter my data set to get rid of the rows that don't match a particular condition, or you can think of it, keeping the rows that do match a particular condition. So for example, I want to filter by those where senior is true. So that's everything that I want to keep. So if you run that, you'll see the data frame that you get back only for the senior column only has trues. And since this is already illogical, I actually don't need this. You can just type that. If that doesn't make sense to you, ask ChatGPT to figure out why this works and why this makes sense. So we're basically almost done. I mean, I can just see already here in this output how many rows there are. But if I want to get that kind of more explicitly, I can just type nrow here. Okay, so that gives me how many rows there are. And I can now divide that by the original number in the population. All right, there we go. So this is the probability of being a senior citizen in New Zealand. So for the other things, I can just do similar stuff. So so diabetic, we can do something similar here. So what's it called? Diabetes. So here, unfortunately, it's a 0, 1, not a true or false, so I need to be explicit. Stupid. Great. So about a 10% probability of a random person being diabetic, and a 15% chance of being a senior citizen. And you know what? Let's actually record these things. So we have that. A couple things that'll make you quicker programmer, and these actually work outside of R too, or a lot of them do. quicker at programming and just kind of text manipulation in general. So if you hold down the, everyone knows here, like I can scroll left and right using the arrow keys up and down. Okay, almost everyone knows that. What a lot of people don't know is that if you do that while you're holding down the Command or Windows key, you go right to the end of the line or right to the beginning of the line. So that's what's happening here. Even better, if you hold down the Option key, or I don't remember what the equivalent on Windows is. I guess like maybe Command or something like that. But if you hold that down and then go left and right, it'll skip words like this. Okay, and then if you hold down Shift while you're doing any of that, you can select stuff. So here, for example, I'm just holding down Shift and going arrow, arrow, arrow. So a very quick way to like change the name of variables. So here, for example, I want to change senior to diabetes, right? So all I'm doing is Control Shift and then left arrow and select that whole word very quickly. I can do something similar up here. Get that. So this will just make you a little bit faster at coding. There's also a, let's see if we can turn this on. There's something really nice that I want to show you too. If you go to Modify Keyboard Shortcuts, here we go. Find and add next, I think. It's this one. Okay. So set this to whatever you want. For me, Command D, because that's what it is in this other text editor I use, but you can do whatever. Set it as whatever you want. And then hit apply. Okay, cool. Now, let's say I want to change diabetes. There I just double clicked, but again, you can do it like this. And I'm going to hit Command D. And this selects other instances of that word. It's a little bit better than find and replace though, because now actually notice I have two cursors here. So I can just change both of these like that. So that's pretty cool. That makes it very easy to kind of like find and replace instances of variable and things like that. You can also do that multi-cursor, like let's say you have like you have something like a bunch of variables that you want to. So you have variable A1, A2, 3. I think if you hold down Alt, or again, I don't know what it is on Windows, but on Mac it's Option. If you hold that down and then drag your cursor, bam, you can name those all something else. So you can get this like multi-cursor. Anyways, play around with that if you want. I find those tips to be helpful, but they're not really crucial to the material of this course, but hopefully they're things that you can use. You can do that stuff in like Microsoft Word too. It's not just R, by the way. Most of that you can do in other environments as well. So, you know, like here on my slides, like I'm Option, left arrow, Option, right arrow, move around like that. All right, but let's get back to this. So we did senior, we did diabetic, and now we need kind of both. So let's say or diabetic, diabetes or senior. Let's do that one. So here we need diabetes, or we can do like this, senior. If you don't understand what's going on here, go review your dplyr, and especially how filter works, how logical conjunctions work in R. So let's get that. And now the last one is and, which we can do like this. Okay, so now we have all those. So let's have a look here. What we saw in the last example here is that you should be able to add these two and subtract off that and get another one. So the or probability is the sum of the two minus the probability for the and case. So let's just see that actually does indeed hold. So how many people have either of these conditions? Should be the same number of people that have one, plus the number of people who have the other, plus or minus the people who I've double counted from that, who are the people who have both. So is that true? Just look at this first number. It's about 20%. The second number is exactly the same. So all we've done here is confirm this that this formula works. This will happen if it's again it's just counting. So we know it has to work, but it kind of doesn't matter what the population data set is that you have. This kind of thing will always work. All right. So we'll come back to this population data set in a little bit. I was just showing you some ways of doing it.